All right, so today we're diving deep into something pretty cool,
Oh, yeah.
sustainable electronics.
Love it.
Specifically, this paper that really caught my eye.
Okay.
It's called Electrical Response and Biodegradation of Sepia Melanin-Shellac Films Printed on Paper.
Catchy.
I know, right?
Yeah.
It was just published in Communications Materials just this past August.
Wow.
And
That's
it's
wow.
got some fascinating stuff about using Cuttlefish ink
Okay.
to make biodegradable electronics.
So we're talking about like really tackling the e-waste problem
Look,
head on.
Well, absolutely. They jump right into it
Okay.
by highlighting how big this issue actually is.
Yeah.
Did you know that in 2019 alone, the world generated 53.6 million metric tons of e-waste?
It's a staggering amount.
It's crazy.
Yeah.
I mean, that's like the weight is over 500,000 blue whales.
It's hard to even fathom.
And, a lot of it ends up in landfills or is improperly recycled.
That's the real problem.
Which is why we need to find more sustainable approaches to manufacturing electronics and, figuring out how to dispose of them.
Right. And this paper really dives into that.
Yeah.
With a concept called sustainable organic electronics.
So for those of us who aren't electrical engineers,
Sure.
what does that actually mean?
Well, it's all about using materials that come from renewable sources.
Okay.
Or that can be synthesized with minimal environmental impact.
Okay.
It's about making electronics that are both functional and eco-friendly.
So less toxic, waste less strain on resources.
Exactly.
Smaller footprint on the planet.
That's the goal.
Win-win.
Definitely.
And this is where things get really interesting.
Okay, I'm intrigued.
The stars of this paper are sepia melanin
Okay.
and shellac.
Interesting.
Two materials you wouldn't typically associate with electronics.
Not at all.
I know sepia melanin is what gives Cuttlefish ink its dark color,
Right.
but I had no idea it could be used to conduct electricity.
It's pretty amazing, isn't it?
It
It's
is.
made up of these tiny particles called nanogranules, and their structure allows for something called electronic conjugation.
So for those of us who aren't chemists,
Right.
can you break that down a bit?
Sure. So basically it means that electrons can flow through the material. Think of it like a chain of people passing buckets of water.
Okay.
Each person represents a building block of the sepia melanin, and the buckets of water represent electrons.
I like that.
The chain allows the water or electrons to flow from one end to the other.
So we're literally harnessing the power of Cuttlefish ink.
Yeah, pretty much.
That's wild.
It is.
And what about the shellac?
So shellac is a natural resin.
Okay.
It comes from a lac bug.
Really?
Yeah.
Huh.
And it acts as the binder in the ink, holding everything together and making it printable.
Okay.
It's got some useful properties for this. Its biosourced forms a good film and is hydrophobic.
Hydrophobic.
Yeah, meaning it repels water.
So it keeps it from getting soggy.
Exactly.
Got it.
They use a technique called flexographic printing to deposit this ink onto paper. That has silver electrodes already patterned on it.
I'm picturing a giant printing press rolling out paper covered in Cuttlefish ink electronics.
It's not too far off.
Okay, so let's get down to it.
Yeah.
How well do these sepia melanin films actually conduct electricity?
So under normal conditions, their conductivity is around 10 to 4 Siemens per centimeter at 2 volts.
Okay, I'm going to be honest.
Yeah,
I have no idea what that means.
fair enough.
Is that good, bad, or somewhere in between?
It's not super high compared to traditional materials like copper,
Okay.
but what's really interesting is that the conductivity changes depending on how much moisture is in the air.
Wait, so you're telling me that humidity affects how well these films conduct electricity?
Exactly.
That's wild.
It is.
I mean, that could open up some cool possibilities for sensors or something.
Definitely a potential application.
Yeah.
So in dry conditions, the sepia melanin primarily conducts electricity through the movement of electrons.
All right.
But when it's exposed to higher humidity, ions in the water start to play a role. And you get this combined ionic electronic conduction that actually increases the current.
So we've got electrons flowing, and then we introduce water, and suddenly ions are joining the party,
That's a great way to visualize it.
boosting the current.
Yeah.
It's like a microscopic rave
I love it.
happening on this piece of paper.
Perfect analogy.
And the shellac is playing a key role here.
Absolutely.
It's acting like a shield, protecting the sepia melanin.
Yes.
But here's what I don't get.
Okay.
The paper itself is actually acting as a source of protons,
That's right.
which are these positively charged particles that are adding to the increased conductivity.
It's this fascinating interplay between all these different materials.
Hold on.
Yeah.
My brain needs a minute.
Take your time.
So we have the paper supplying protons,
Uh-huh.
the sepia melanin conducting electrons,
Uh-huh.
and the shellac is like fending off the water.
It's teamwork.
Yeah.
At a microscopic level.
Incredible.
Now, you might be wondering about the durability,
I was just thinking that.
especially with the paper being a key component.
Yeah, if they're biodegradable,
Right?
could they just fall apart if they get wet?
It's a good question and something that needs further study.
Okay.
But they did discover that heating the film to 70 degrees Celsius for an hour increased its conductivity.
Heat, though.
Yeah.
Why would they do that?
It seems that the heat softens the shellac,
Okay.
allowing the sepia melanin particles to get closer together.
Okay.
And that improves electron flow.
So a little sauna time for the Cuttlefish ink
You got it.
gives it a conductivity boost.
Exactly.
Interesting. But let's get to the part I'm really curious about.
Yeah.
How biodegradable are these films? Can we just toss them in the compost when we're done?
They put them through a standard composting process.
Okay.
High temperatures, moisture, and air.
Uh-huh.
And the results were pretty amazing.
Okay. I'm on the edge of my seat.
The printed films reached 97% biodegradation in just 85 days.
97%.
Yeah,
That's incredible.
it
They
is.
practically vanished
Pretty much.
in a matter of months.
Yeah,
Did they compare that to the individual components?
they did.
Okay.
Cellulose, the main component of paper,
Ah.
degraded about 87% in the same time frame,
Okay.
which was expected.
Makes sense.
Sepia melanin came in at 33%,
Right.
but shellac lagged behind at just 12%.
So the printed film actually biodegrades faster than some of its individual parts.
This is a fascinating finding.
How is that possible?
They think that the combination of all the materials in the film, along with the silver electrodes, might be enhancing the breakdown process. They think the paper's ability to absorb water plays a key role,
Okay.
making the whole structure more accessible to the microbes that do the composting work.
It's like they're all working together to
Right.
break down faster.
Yeah.
Pretty cool.
It is.
But what about the byproducts of that breakdown?
Right.
Are they safe for the environment?
Well, to answer that, they took a really interesting approach. They looked at how the composted material affected plants.
Okay, so they made little cuttlefish ink gardens.
Not exactly. They used ryegrass and marigold seeds
Okay.
and planted them in compost that had the leftover bits of the printed films.
Got it.
They also planted seeds in regular compost, just to compare,
Makes sense.
and in compost with nickel chloride, which is known to be harmful to plants.
So like a control group
Yeah,
to
exactly.
see if the composted electronics would mess things up.
Right, and the results were good news.
Okay.
No negative effects on seed germination or growth.
That's awesome.
The ryegrass and marigold seeds sprouted and grew just as well as in the normal compost.
So they break down and they don't hurt plants. That's amazing.
It is.
But okay, did they actually make any working devices with these films?
Well, this paper focuses more on the properties of the materials themselves.
Right.
But it does hint at some really exciting potential applications.
Okay, like what?
Biodegradable energy storage devices, like supercapacitors and even solar cells, all based on sepia melanin.
Wait, biodegradable solar panels.
Imagine.
That's straight out of sci-fi.
Right.
Solar panels that could power your home for years and then just decompose back into the earth.
Pretty cool, huh?
That's incredible.
And then there are supercapacitors.
Okay, remind me what those are again.
They're like superpowered batteries.
Okay.
They can store a lot of energy really quickly and release it just as fast. They're used in things like electric vehicles and backup power systems.
So if we could make those biodegradable too,
It would be a huge step forward.
it'd be huge for the environment.
Absolutely.
Like we're talking about a whole new era of electronics
I think you're right.
where devices are designed to be both functional and sustainable.
Exactly. And this paper is a big step towards that vision.
It makes you wonder what other amazing materials are out there in nature,
There are probably countless possibilities.
just waiting to be discovered.
Yeah. And that's what's so cool about this field.
Yeah.
It's this fusion of biology and technology
Definitely.
with endless potential for innovation.
Okay, so we've talked about the problem of e-waste, the unique properties of sepia melanin and shellac,
Yes.
and the amazing biodegradability of these printed films,
We've even touched on some potential applications.
right, like solar panels and supercapacitors.
And we've seen how this research challenges us to think differently about the entire life cycle of a product.
From its creation to its disposal.
It's a reminder that sustainability isn't just about materials.
Yeah, it's about designing with the end in mind.
Exactly. And that's what I find so compelling about this research.
G2.
It's not just a cool new material.
That's a whole new perspective.
A more harmonious relationship between technology and the environment.
It's like we're finally starting to design electronics that fit into the natural world.
Instead of disrupting it.
Yeah, exactly.
We're seeing the emergence of a new paradigm where nature isn't just a resource.
It's an inspiration.
And a source of solutions.
Okay, but before we get too excited about all this,
Sure.
we need to be realistic about the challenges
Of course. There are hurdles.
to making this a reality.
Yeah.
For example, we talked about how the silver in these films might be helping with biodegradation.
Uh-huh.
But silver is a heavy metal, right?
It is.
Aren't those bad for the environment?
That's a good point, and it's something the researchers acknowledge. The amount of silver used in these films is pretty small.
Yeah.
But we still need to understand what happens to it long term.
Right. Just because it breaks down
Yeah.
doesn't mean it disappears.
Exactly.
Could it leach out of the compost
It's possible.
and end up back in the environment?
That's why more research is needed.
It's a good reminder that even with sustainable technologies,
Yeah.
we need to be careful,
We need to be thorough.
not create new problems while solving old ones.
Absolutely. A holistic approach is essential.
And what about the cost of all this?
Ah, yes. The economics.
If biodegradable electronics are going to be way more expensive than regular devices,
Yeah.
are people really going to buy them?
That's a valid concern.
That seems like a major roadblock.
It's a challenge for sure.
It's great to have these new materials, but
Yeah.
if they're too expensive,
It's not going to work.
they're not going to make a difference.
Right. And it's a complex issue.
Okay.
Scalability is a big one.
Hmm.
Right now, a lot of these sustainable materials are produced in small quantities.
Yeah, which makes them expensive.
Exactly. Classic supply and demand.
So we need to figure out how to make more of them.
More efficiently and at a larger scale.
Exactly.
If we can bring down the production costs.
Then the final products will be more affordable.
Right.
But it's not just about the materials themselves, right?
No.
The manufacturing processes have to be sustainable too
You got it.
and cost effective.
We need to develop processes that minimize waste,
Okay.
reduce energy consumption,
Yeah.
and limit the use of harmful chemicals.
Like rethinking manufacturing from the ground up
Exactly.
with sustainability as the core principle.
And that requires collaboration between scientists, engineers, economists, policymakers.
Everyone needs to be on board.
It's a big task.
Yeah.
But an important one.
Okay, but amidst all these challenges, there's some hope too, right?
Oh, definitely. Like what?
Well, consumer awareness is growing.
You mean about e-waste?
Yes. People are starting to understand the environmental impact of their electronics.
It's true. People are becoming more conscious of what they buy.
And they're starting to demand products that reflect their values.
Yeah.
This growing awareness is driving demand for more sustainable options.
So companies are starting to listen.
They are. They're seeing that there's a market for it.
And they're investing in these new technologies.
Exactly. It's like a ripple effect.
Consumer demand is driving innovation.
I like that.
And it's not just consumers.
No.
Governments are getting involved too.
Absolutely.
Right.
They're addressing the e-waste problem through laws and incentives.
Like what kind of initiatives?
Well, a lot of countries are implementing extended producer responsibility programs. What are those?
Basically, they require manufacturers to take responsibility for collecting and recycling their products.
At the end of their life.
Yes.
So it's like a built-in incentive for companies to design for recyclability
Exactly.
and to use more sustainable materials.
Right.
That's great.
It's a shift in thinking
Yeah.
from just selling a product
To thinking about what happens to it later.
to considering the entire life cycle.
So we're seeing this multi-pronged approach emerging.
I think so.
Consumers, companies, governments,
all working together.
like to create a more sustainable future for electronics.
It's exciting to see.
It feels like we're on the verge of something big.
I agree.
But beyond all the policy and corporate stuff,
Yeah.
there's another piece to this puzzle.
What's that?
Education.
Absolutely.
We need to teach people about the hidden costs of electronics.
The environmental and social costs?
It's easy to forget that our gadgets have a life beyond our own use.
Right. They don't just disappear when we're done with them.
We need to raise awareness about the effects of e-waste.
The toxic chemicals, the exploitation of workers.
It's a tough reality to face.
It is.
But education isn't just about the negative stuff.
No.
It's also about highlighting the positive potential of these sustainable alternatives.
Like those sepia melanin films.
Exactly. Those stories were so inspiring.
They give us hope.
Yeah, they show us that a better future is possible.
And those stories need to be shared.
With everyone.
Yes, not just scientists and tech people.
We need to make this information accessible to everyone.
Through podcasts, documentaries, educational programs, social media.
Yeah, reach people where they are.
Spark a conversation.
About sustainability.
Give people the knowledge and tools.
To make informed decisions.
About the technology they use.
And to demand better options from companies.
It's about empowering people to be part of the solution.
It's a collective effort.
And everyone has a role to play.
Yeah, it really feels like we're seeing a change happening. Like sustainability is becoming a much bigger deal.
Yeah, I think you're right. It's not just a fringe idea anymore.
So we've covered a lot today.
We have.
The potential of these biodegradable electronics. The economics of making sustainable tech a reality.
Right.
And the importance of education.
Absolutely.
Cuttlefish ink, solar panels, compostable smartphones.
It's been quite a ride.
It really has. But before we wrap up,
Yeah.
I want to go back to this idea of biomimicry,
Oh, yeah.
which we talked about a little earlier.
That's a good one.
This whole paper about sepia melanin films.
Yeah.
That's a perfect example.
It is. We're basically learning from nature to create better tech.
It's like we're looking at nature's designs and saying, okay, how can we apply this to our own inventions?
Exactly. Nature has had millions of years to perfect these strategies.
So we're kind of cheating a little bit,
I guess you could say that.
but in a good way.
Yeah, for sure.
And the cool thing is, biomimicry isn't just limited to electronics.
Right. It's being used everywhere.
Really?
Oh, yeah.
Like where?
Architecture, transportation, medicine, energy,
Wow.
all sorts of fields.
Give me some examples.
Okay, well, architects are designing buildings that mimic termite mounds.
Termite mounds.
Yeah. To create structures that are naturally cool and energy efficient.
So we're learning from termites to build better buildings.
Pretty much.
That's wild.
And then you have engineers designing wind turbine blades
Yo.
that are inspired by humpback whale fins
What?
to reduce noise and improve energy capture.
That's incredible.
And medical researchers are studying gecko feet
Gecko feed.
to create new biocompatible adhesives.
So we're basically stealing ideas from nature,
Well, borrowing
borrowing,
and adapting.
and using them to solve our own problems.
Exactly.
That's pretty brilliant.
It is. And the more we explore nature,
Uh-huh.
the more potential we find for sustainable solutions.
This gives me so much hope.
Me too.
It's like we're finally starting to design things that actually work with the natural world.
Instead of against it,
Yeah.
it's a whole new way of thinking about design.
It is. It's a paradigm shift.
With the power to change our relationship with technology and the planet.
So what's the one thing you want our listeners to take away from all of this?
The future technology is not just about making things faster and more powerful.
It's about sustainability
It's about equity.
and designing things that are in harmony with the natural world.
Exactly.
Well said. So let's all do our part to create a brighter, greener, more sustainable future for electronics and for ourselves. Thanks for joining us today on the Deep Dive